So now we're going to talk about the volume and surface area of spheres. And just to remind you, I think you all know what a sphere is, but technically it is the set of all points in space equidistant from a given point called the center. All right, so here's our center. The sphere is made up of all these points that are the same distance away from that center. The radius is the segment that has one endpoint on the center and the other endpoint is on the sphere. So I have infinitely many radii, so that goes all over the sphere. And then a diameter is a segment passing through the center with endpoints on the sphere. So if I made this connected, then that would be one diameter. And again, there are several diameters in a sphere. All right, so just like in circles, we have some of the same things like radii and diameter. All right, we have a center, and then we can also have chords. Notice that this chord goes from a point on a sphere to another point on the sphere, but it does not necessarily contain the center. Remember, the diameter has to contain the center. All right, some other important vocabulary. When we have planes cutting into a sphere, whenever we have that plane, that cross section is going to be a circle. All right, and then if that center of that circle is also the center of the sphere, we call that the great circle. There are other circles that we could have as intersections. So for example, this one is also a circle, but this plane is up here. So you see how this plane is cutting right through the middle. So the great circle is where like your hemisphere is, your equator, if you think about the Earth. And it divides the sphere into two congruent hemispheres. All right, so the circumference of the great circle is also what we consider the circumference of the sphere. Okay, so keep that in mind too. This is just some pictures of previous students, how we peeled an orange to help us find the surface area of a sphere. So they took all of their orange peels and then they laid them out and they filled them all in. And what happened was they could fill in all of their orange peels into this rectangle that was 2 pi r in length and 2 r in height. And that was 4 pi r squared. Another way of thinking of that is looking at a baseball. A baseball is a sphere and the covering is like the surface area. If you uncover it, it looks like this shape. Okay, these would be like where the stitches are. And they kind of look like 4 circles. Okay, they're not quite that because they have to connect them. But if we were to make this as basic as possible, we would have 4 circles and that would be 4 pi r squared. So our surface area of a sphere is simply 4 pi r squared. All right, and so we're going to do the surface area of these 2 spheres, and notice what is going to happen. So my question is when the radius doubles, does the surface area double? So let's figure that out. So here our surface area is going to be 4 pi times 3 squared. So this is going to be 9 times 4, which is 36 pi. All right, over here, I'm going to have the surface area is 4 pi 6 squared. So this is going to be 36 times 4, which is 144 pi. So is 144 pi double of what 36 pi is? Well, if you do 144 divided by 36, this is actually 4 times as big. As that. Okay, and that's because surface area has units squared. So if I double one of those linear units, then I'm going to have to square that because it's going to be in units squared. So surface area always doubles that ratio. So if I double the radius, then I'm going to quadruple that surface area. All right, so now let's look at this problem. We have the circumference of a great circle of a sphere is 7.4 pi feet is the circumference. So we want to know what is the surface area. Well, for surface area, we need the radius. So we're going to use the circumference to help us find that. Remember, circumference is equal to 2 pi r. So I'm going to cancel out the pi's, and then the r is going to be 7.4 divided by 2. So the radius is 3.7, and now I can plug that back into my surface area formula. And that would be, let's see, 3.7 squared times 4 is 54.76 pi. Okay, so later in class I'll show you Archimedes' hat box theorem. It's kind of cool, and that'll help us do a problem like this with the surface area of a certain zone on the Earth. Now let's talk about volume of a sphere. If you consider, if I take from the center of the sphere and make these pyramids, okay, tiny little pyramids, okay, now it wouldn't be exactly a circle, these would all be flat edges, but these are like square pyramids. Okay, I would have just a volume of one single one of those is 1/3 area of the base times height, right? So the sum of all of those volumes is going to be however many of them I have. So if I had 1,000,000 of them, then I would do 1,000,000 times 1/3 area of the base times height. Now the height of each of these pyramids is simply the radius of the sphere. So I'm going to replace that with r instead of h. Okay. So then the other thing I'm going to consider is if I have a million of these bases, right? I've got these square bases going on. Think about what that covers. If I add all of them up, that should cover the surface area of the sphere, right? Because all of those little squares would combine to give you this blanket across the surface of the sphere. So we already know that the surface area of the sphere is 4 pi r squared. And then this r came from here. And we still have that 1/3. So if I simplify all of that, I'm going to get 4/3 pi r cubed, right? And that's why we know that the volume of a sphere is going to be 4/3 pi r cubed. Here's another way of thinking of it as well. If I took a sphere and a cylinder with the same radius, all right, that cylinder we know is pi r squared h. So and then I replace that height with 2r. So my height is the same thing as 2 times my radius. So if I could try to squeeze as many spheres in as possible, I could really fit about 2/3 of that sphere in that. So if I multiply that together, that would be 4 pi r cubed. All right, so bottom line is that our volume is going to be 4/3 pi r cubed. Notice that this is very important. This is r to the 3rd power. So think volume is units cubed, and that's r to the 3rd power. So just be careful with that. So if I were to find the volume of these two spheres, notice that we're going to be rounding to 2 decimal places. So we'll get our calculators out. So 4/3 pi, I'm going to be doing 5 to the 3rd power. 5 to the 3rd power is simply 125, and I'm going to multiply that by 4/3, and then multiply that by pi. So that I'm getting approximately 523.6, oh no, I have to do 2 decimal places. Yeah, that would be 6.0 feet cubed. All right, and then you can do the same thing over here. I think you guys get the idea. This is more of just plugging it in and typing that into your calculator. So 6.5 to the 3rd power is 274.625. And then we're going to multiply by 4/3. And then by pi. So I'm getting approximately 1150.35. Okay, units cubed. All right, so let's look at this example. What is the radius of a sphere made from the cylinder of modeling clay shown? So it's like we have this clay someone already made the cylinder out of modeling clay, and we're going to ball it up and make it into a sphere. So if I'm using that same amount of clay, then we can assume that the sphere has the same volume as the cylinder. So first we need to find the volume of this cylinder. So remember that volume of a cylinder is pi r squared h. So that's going to be pi times 5 squared times 15. So that's 375 pi. That's our volume. So we're going to set that equal to 375 pi is going to be equal to the volume of our sphere, which we just said is 4/3 pi r cubed. Okay, so the pi's cancel. And I'm going to divide by the 4/3 or multiply by the reciprocal 3/4. So 375 times 3/4 is going to give me 1125 over 4. I don't want to round yet. And then to solve for r, I'm going to be taking the cubed root because I have to cancel out with that r cubed. So I'm going to approximate here. So I could just leave it like that if I wanted an exact answer. But if I do the cubed root, I'm getting approximately 6.55, and that would be centimeters. Because over here we were using centimeters. All right, so that's a really good problem of using our volume and equivalent volumes and then finding a certain dimension. All right, so here's our summary. Surface area of a sphere is 4 pi r squared. Volume of a sphere is 4/3 pi r cubed. And then, like I said, we're going to do more advanced problems in class.